Hey, hi everyone. Recently, I created video on LangChain RAG course. Basically, I created a RAG application, which is Retrieval-Augmented Generation chatbot using the LangChain framework. And some of you reach out to me saying that you want to build the RAG application, but you don't want to use any framework like LangChain or the LlamaIndex. And then I thought of, okay, let's create a tutorial video where we show you how to create the conversational RAG application with the original API like OpenAI API, ChromaDB, because many of you says that debugging LangChain and LlamaIndex application becomes tricky. You need to know very well. You need to have good hands on with the LangChain, and sometimes you get stuck into that layers of documentation without getting what's exactly happening under the hood. So that's good. We also used to build earlier application directly using the what you call their direct APIs, whether it's a ChromaDB, OpenAI, or something. We still use the LangChain, but I also agree that we get more control if you build this without any particular framework. So let's try to do this thing in particular in this video. So okay, we will come to this diagram. Maybe first of all, let me tell you what exactly we're going to cover. And the first thing we will do is actually cover the document processing and indexing. So how do we handle our documents? So I got some set of documents. These are the same documents which I have already covered in this video, which is the LangChain track course. So I'm going to use those similar documents and their example. Then we will see how do we initiate or set up the ChromaDB. How do we then take these process documents and insert into the vector database, and finally do some semantic search so that we could see if I pass any query like here. If I have any query and if I do the semantic search, am I getting the retrieve context which is related to the query I ask, which is nothing but the semantic search. And then we will see how do we take the retrieve context, the original query, how do we maintain the conversational memory or chat history, and then final prompt which has all this information goes to LLM. We get the response and we again maintain our conversation. So I try to keep things simple, right? So that's what we're gonna cover this video. So first of all, if you're not familiar with let's say what is RAG or retrieval augmented generation, basically retrieval augmented generation, the RAG allows us to bring an external knowledge. This knowledge, proprietary knowledge, your own documents, your company documents, that knowledge we are able to bring to the LLM, because you might have certain queries which this LLM might not aware of. Those details. It could be this LLM didn't have access to those documents, or it is also possible that the details what you have is actually created or got into the existence after the training of this LLM. So what RAG does, which is nothing but this retrieval augmented generation. See, generation means you are generating the response for the user. That's the generation part. Retrieval means what? You are taking a user query and you are finding the similar documents which could answer that query, and you bring those documents. That's nothing but the retrieval. So when you take this retrieval document and you generate the response by augmenting this information to the LLM, we call it retrieval augmented generation. That's the whole idea. So let's do some hands-on in this particular collab notebook, and as I mentioned, we will cover this detail. What we just saw. I think this is the same image what you see here. I just put that image. So one of my team member has created this image, which is what we saw here. So what next? So first thing we will focus on, let's say installing these libraries. I think I already ran and installed this thing. So what we are installing? We are installing ChromaDB, which is a vector database, a OpenAI library as an LLM API. We could use the different one also, like Anthropic, Cloud. We could use anything. We are using some libraries because we want to process those documents on our own. This is for PDF. This is for the DOCX. I think we need to check whether I'm using this or not for now. Then we are using this for the sentence transformer, basically for the I think this is repetitive, this part, for the embedding purpose. So let's go next. Okay, first of all, let's look at what exactly the document processing and indexing looks like. Now we are not using the LangChain, but this particular image I took from the LangChain website. So we are talking about this part. We got some documents, and we want to convert those documents or process those documents in a certain form so that it become easy when user ask a query to bring the relevant documents back. This part is nothing but the semantic search, and to make it happen, we generally call this process called indexing. Basically, you are indexing this document inside the vector database, and this indexing goes through the set of stages or set of steps, you can call it. So first thing, we load this document. Let's imagine those documents are there in some folder or some directory. So we load those documents. They could be different type. Currently, I think I only consider docx and the PDF, which is more popular documents. And then we need to split those documents. So you could actually insert whole big document also in the vector database. So basically, if you split those documents, you can get the better matching when you match with the query. And it is also possible that out of that big document, maybe only a certain section of that document, let's say 20% of document is relevant to the user query. If you put all that document, everything into that one single document, you are bringing an unnecessary information which LLM don't require, right? It is also increasing the cost, because the cost is associated with the number of words or the tokens you got there, right? So it's always a good idea to split your documents into the smaller chunks, like 500 character, 1000 characters, depends on your use case. So we will first split our documents, and then we will do some embedding, because see, in NLP, whenever we want to match user query with some documents here, we will be converting user query into the embedding, and we will already have the embedding presence here. So when you process those documents, we already created embedding for those chunks. So when we do this process, we have to define which embedding we are using. Either we are using, let's open source embedding like sentence transformer, or even the OpenAI provides embedding, and then eventually we store this thing into the vector database, right? So this small box what you see here actually has this couple of stages. So let's start with the simple. So first of all, I have defined few functions. So I define one function. If the file is text file, I'm going to simply open that file in the reading mode, and I'm going to read its content. Very simple. If it is a simple text file, then this function, if my file is a PDF file, then I'm using this py PDF to reader. I read this thing, I iterate through each of these pages and extract each page content and collect all that content in this text variable. So basically, when this function runs on a particular file, we get all the extracted pages content as a big string, right? And similarly we do with the docx file. So we are using this docx library, which again iterate through all the paragraphs present in that particular document, and we join all of them using the new line character. We do the same thing here. Each page content we are anyway joining with the new line character, so that we get big file read as a single string kind of application. So simple three function: text, PDF, and the docx reading. Now I created one single function which will take any file path, and then it will check, is it text, is it PDF, or is it docx, and it will call accordingly this function. That's what it does. Let me show you how it works. So here I took one file which is from here. Let's say this company history document, and let's call it. Did I run this one? Okay, let's run this one, and you can see now what's happening. Okay, OS is not defined. Didn't we import? Let's do the import OS. Okay, you see we are able to extract that text. So this was the docx. So basically, the docx part, this function would have called, and we got all the content extracted from our file. So that's the job of this thing, simply extracting the loading content. Where it is, I think it is above. Okay, so this is still here somewhere. The loading the content, we are able to read the content from that particular file. Now it's time to do the chunking. Sorry, why I'm coming here. Maybe I open that file also similar way. Yep. So yeah, now we want to see how do we split. Now we got the chunk. We are able to extract either PDF or the docking. Let's chunk into the smaller parts. Okay, so we got this function, which is gonna take our original text, what we got from the above function, and basically split that text into the smaller chunk where we could specify what chunk size we want to keep. Here the chunk size is in character, so we are saying that each chunk has to be the 500 characters of this text. Now here what we are doing, okay, we are taking this big text and again creating the sentences, which is the list of your sentences, because we are splitting them on a what is this, full stop. So we get list of sentences here. Here we're going to collect all the chunks we are getting from that text, whatever we are passing. We will track what is the current chunk. Basically what we're going to do, we have this list of sentences we got for all the text we extracted, and what we will do, we will take one sentence at a time, and we will put inside the current chunk, and we will keep adding those sentences inside this current chunk till the chunk size is less than 500. The moment this current chunk size exceeded this 500, we will stop adding, and we will simply take that current chunk, add to the chunks. Now because we got a chunk which is, let's say, less than 500, and we can't add more sentences to it, so that becomes the chunk. And whatever that sentence which actually overflow that 500 character limit, that sentence will become again the part of the current chunk, and the new process starts, right? That's what happening here. So you see here, we are iterating through the sentences. We remove any space if it is high. If there is, let's say, nothing, we simply continue. Now we check if the sentence is not ending with the dot. We just add this. I think, I'm not sure whether this was necessary. We just generated this code, and it just take care of adding the dot at the end if it is not ending with that particular thing. So we take this current sentence and we calculate what is its size, because we want to make sure if I add this sentence, it should not exceed more than 500 character. Now we already have a current size here, which we started with the 0, let's say. And then we will check if I take the current size of the chunk, and if I add the new sentence which I currently got, is it exceeding the chunk size? Now if it is exceeding the chunk size, means we can't add and our current chunk is done. So what we will do, we will add our current chunk to the chunks. So we're going to add that thing here. And what we will do, once we add that current chunk here, our new chunk, which is the sentence what we got, it's the start of the new chunk. And basically we will also update the current chunk size, which is the size of the sentence that we got. This will happen if adding this sentence exceeding our chunk size, and basically we are taking the previous chunk and add it to our chunk list. But if adding doesn't exceed, it means we will simply increment our current chunk sentences. So we will add the sentence to our current chunk and we will increase the current chunk size. This will all finishes. Then whatever the final chunk will remain, if it is there, we will also add. Now it might be anything, it will be 200 character, 10 characters, whatever, that will become the final chunk. So this is what happening in the chunking. We are iterating through each sentence and we are creating the chunk till they become a 500 characters. So this is the first chunk. Maybe if I look at the second chunk, right? So this is up. So you can see how many chunks we got. We might have got, let's see. So we got a 5 chunks. Okay, so till this point is done. Now we are able to split this particular, using this function, we can pass any text what we got and we can split this particular thing. Now let's, make sure we set up the ChromaDB, because ChromaDB has a utility using which we can embed and store in a single, step. So we are importing ChromaDB because we already, install it. And we are also importing one of its utility, which indicate which embedding functions we could use. Now we are specifying that ChromaDB persist. This is when you want to make sure that you are storing your ChromaDB. Now we are specifying that I want to store in this function called ChromaDB. If I check here, currently there will be nothing. Once I run this, we should see a ChromaDB appearing here. And we could, using this embedding function, we could also specify which embedding we want to use. So we want to use sentence transformer embedding. We can specify which model we want to use. So this is the embedding that we could use. And when I create the ChromaDB collection. So collection you can think of like a table in the relational database, that kind of thing. So I create a collection. Let's give it a name called documents collection, and we can pass which embedding function we want to use when you insert document inside this collection. So we are saying we want to use the sentence transformer. That's what I told you. These two steps, embedding and storing, will happen same time when we add document to the ChromaDB. I think I also have a video on the ChromaDB, which might be older, like 1 year old maybe, but I think concepts are same. So if you want to understand in more detail semantic search ChromaDB, then I have a dedicated video that you can check. Okay, so let's create this collection, and we should be seeing our ChromaDB appearing here. Yes, here is our ChromaDB, right? And this is, I guess, it is also downloading this particular model because we want to use that model. Okay, it's taking some time. I think it has downloaded the relevant files required for that model. We have this thing. Now it's time to insert the documents. Since we got the collection, we got our chunks also ready, we could insert. So we create one function. This function is for the process document. What is actually doing, we have defined certain utility function above. So we have a function which can decide which processing to call, and then simply give us text back. We also have one more function which take that text and give us the chunks back. Now what this does, process document function, which calls our that read content, so that we get the content, we get the chunks, and it created the three things that we want to insert into the collection. The first thing is definitely the chunks itself. The second thing is the metadata. So we want to make sure we add some metadata to it, so that using that metadata we can filter or search thing. Now what here we are adding inside the metadata, so for every chunk we are iterating to the chunk, and we are creating one dictionary for that chunk. That dictionary has a source metadata key. So source is the file name we are storing, from which file it came, and also another property we are storing, the chunk is one. So basically this will be like, if I take any file, the source will be the name of this file, and the chunk will be 1 2 3 4 whatever. So right, if this file has 3 chunks, all of them we have a same source name, and basically the chunk number will be different. So that's the metadata. So we got the list of chunks, and we also got the list of metadata for each of that chunk, and finally we have to give some unique IDs to it, and we are creating unique ID using the name of the file and the chunk number. So the IDs will become file name underscore chunk and that particular number. So this is basically taking a file path, using our those all functions and give us this nice three things that we could use. And then these three things we will be using in the add to collection function. And this add to collection function simply gonna take our collection, those IDs takes are nothing but those chunks and the metadata, and it's gonna call a method called collection.add. It takes our list of documents, basically the list of chunks, list of metadata, list of IDs. Simply whatever we got, it's gonna insert. What is this happening here? Basically, you might have many documents on pages, thousands of, right? So this function take cares that at a time we are only inserting 100 those chunks at a time. That's what this particular part is doing. Most important part is this: what we are adding: documents, metadata, and IDs. Okay, so I think we got a lot of utilities here. Now it's time to finally put them in a single thing where we could pass our folder path, and then everything happens. Basically these all documents go inside the this particular thing. Now we want to see everything, this whole part, passing documents directly to the ChromaDB. So we have this function which take our folder path like this, the docs folder. It finds out all the files present in this folder, which is this. Then it iterates through each of the file path, right? And calling our process document function, which we saw on the top, which basically gives all the chunks of that file, their metadata and their IDs. The next thing, once we got this thing, it is calling this add collection. So basically this function take care of doing all the stuff that we want to achieve to put those documents inside the ChromaDB. It's basically calling the above function that we have already discussed. Okay, let's try now. So I'm calling this process and add documents and give me the I'm giving this folder path, and hopefully all of these pages goes to our ChromaDB. Okay, so it's processing this file, green grow eco harvest. There were 6 chunks in that file. Then we got the other file that has 2 5 1 2. So I think all of these files are processed one by one using all the utility functions what we have specified on the top. Now it's time to test it whether our data. I think we are done with this, but let's take this one here. Now we know our knowledge base is ready. We want to take any user query and see whether we can find the relevant context or not only this part. So I'm creating one function called semantic search, which takes our name of the collection, or let's say the collection, whatever we want to pass. And we are passing a query, and we are calling this collection with our query and want to get the number of, let's say 2 matching documents, 3 matching documents, something like that. Now let's run this thing. Okay, we got something back. So see, we passed this query and we wanted to get the relevant documents from this collection. This is how the results look like. So this results, what it has, this result has list of IDs. This one, since we have asked for how many 2 documents, we see 2 IDs, which is the file name and the chunk number. So I think the file name is same. The 0th chunk and the 4th chunk has match. This is that actual document which we can see here. The first document and the second document, and these are their metadata. This is the first document metadata up to this point. This is the second document metadata what we got, and this is their distance. So first chunk is more closer than this second chunk. Now let's see what it has. We asked for when was this founded, and we could see there is some information about the founding of this company in the first chunk. Here we got some information here. So at least semantic search is working. We are able to retrieve the relevant document for what we are asking. Now we want to extract this information properly. Okay, let me run this. So basically if you look at, when we query collection, even though there is a single query, we pass it as a list of query, even though it's a single query. And similarly, when we get those documents back, we get these documents as a list, and each element of it also a list. So it is a list of list. So basically this is the document's 0th element, and that 0th element have all our documents. So that's what here what we are doing. So this everything is inside this documents dot zero, and each of that document we are simply printing those value. So this is the nicely we print the result one, the name of the file and the chunk identifier. This is the content what we got. This you could ignore, like basically what we don't need to remember anything. We just want to see what they are returning and access those indexes. Okay, now we want to make sure, because if you look at our diagram again, we are able to get the good context back here. Now we want to make sure this multiple document nicely formatted as a string goes inside the prompt. To do that thing, we will create one function get context with sources, which will take our results what we got this one, and it will give the context. Basically this text is become the context and the sources information. Nothing but what we just did here while printing, it will do the same by the function. So this is what we do. We take the results documents.0, whatever the documents are there, and we nicely concatenate those documents using two new line characters. So that is nothing but the context that will go here in the prompt. And we will also return the sources, because we know the sources information is inside the metadata. And let's see what we get here. You can see here that we got this context nicely added, using two new line characters what we got. Now it's time to combine this thing. Till the point we are doing all of this thing, right? We did this part up to this. Now it's point to bring LLM and then call LLM with our context. So we're gonna use the OpenAI LLM, and we're gonna use it's a chat completion API. If you're not I think you're definitely familiar with this thing. If you're not familiar, then you should watch any tutorial on how to use OpenAI API. But I'm gonna tell you simple way. So yeah, I'm using the Python. So this is one of the endpoint of the OpenAI, which is the chat completion API. We are calling it chat because we are passing chat or the conversation as input. So basically, you can say these are the messages we are passing. Each message represent the role of the message, like who is sending. Is it a user? Is it a assistant, which is basically an AI, or is it a system message? System message is basically for a bot to give some kind of a character, like you are an helpful assistant or something like that. And you can, if you want to ask anything, you can ask under the user, you can even under the system you can ask. But the convention is system message is to give some kind of overall instruction, thing. And anything dynamic we want to send, we can send as a user input. So this is typical, OpenAI API looks like. Let's call it, simply. Before calling, we want to make sure that we got the OpenAI API key. So once we have the OpenAI API key, we can set it as an environment variable so that it's get available whenever you make an OpenAI call. So let's say I'm calling a chat completions endpoint. I'm specifying which model, and I'm also specifying the conversation, which is basically a simple message. I'm asking what is RAG, and in a simple words I want to know what exactly the RAG. Let's see what we get back. Okay, you can see we got a message of type called chat completion, and then it got a variable called choices. Then if you look at the first element of a choice, which is actually a message of chat completion message, and it has a content. Like, this is how their hierarchy is there. We know that inside the completion we want to take the first choice and then message and its content, and we can print it. So this is what retrieval augmented generation, what according to the OpenAI LLM. So this is how we call OpenAI API. Okay, now let's go to the next point. Now we're going to require one function, right? We saw here that ultimately final prompt is going to be the some prompt instruction, our query and the context. So we're going to create one function which will take our query and the context and will give us the nice prompt with those placeholder context and query. And this is the function where we're going to call our OpenAI API. So we will receive the query. We will use above function to get the proper prompt, and then basically we will call the OpenAI API with the given prompt. Pretty simple, just like what we did. Instead of calling this hard-coded prompt here, we're gonna create this prompt using this above syntax, which is typical RAG question answering prompt, that based on the following context, please answer the question. And if you don't know the answer, then simply say that I can't answer based on this information. Okay, now it's time to perform the real RAG query. So we're gonna retrieve the context and then we're actually gonna generate the response. So for that, we define this function called RAG query, which takes our collection, the query, and how many chunks to consider. Let's keep it two only. Then it performs the semantic search. We have already seen what semantic search does. Semantic search brings these results back, which is nothing but the matching documents and their metadata. Then we got one function which simply take the results and give us the context and the sources information. It basically take all this document nicely format into the long string. So we got the context, and then we call the generate response. So we take a query and we take a context and we call this generate response. This generate response internally generating the prompt using the above function. And finally, it return the response with the sources information. So let's run it and see what happens. Generate response is not defined. Let's run the above cell. Okay, so we ask for when was this green grow innovations founded, and we got answer back saying that it's in 2010, which is the correct answer because we have seen a matching document that has this information you see here. So we completed this part. Up to this part, everything from user here. So we are able to construct the dynamic prompt using the relevant matching context from the database and basically call OpenAI LLM. Okay, so we got, this is the RAG. So we got the RAG part working now. Now it's time to, you know, combine this all these informations. So let me see, and make it a conversational RAG here, right? So conversational RAG means, first of all, we should be able to remember the chat history, so that if I pass that chat history, it knows what was the earlier conversation between, let's say, user and the chat GPT, because chat GPT don't remember anything about you. And we need to do something to store this conversational memory. And also, though it is not shown in this particular document, we will see how do we handle the follow-up question, because when you have a RAG application, there are some challenges when you ask the follow-up question because it's not the complete. I will give you an example. Let me go back here, let me close this one. So let's see what utilities we have, first of all, to maintain that conversation. So we created one dictionary. We are not using database at the moment. If you want to see, you can check my this video. In this video, I have shown how do we maintain the session or the conversation, all these things using the database, right? If you want to do that, basically that comes under the productionizing your RAG application. You can check there. Here I am more focused on the concept at the moment, that how do we maintain the conversation. You can replace this dictionary with your database and you will have things working. So I create one function to generate the session. Why session? Because your chatbot will be used by the multiple users, and each user can have a different. Let's say if I go here, the moment I click a new chat, it's actually the new session that I'm creating with the chat GPT, which will have its own conversation and its messages. Similarly, we want to make sure that we have some unique identifier whenever user initiates a new session. So this is what this, using this function, we use this library UID to create some unique identifier. Then we also have one function which will add a message to our conversation. So whenever user asks something, this whole process happens, you get the user query and you get the LLM response. You want to add that thing to your conversational memory or a chatbot history, so that you can pick up that same history when the user asks the next question with the same session ID, right? So here we take a session ID, and we take the, basically role is nothing but whether this message is coming from the user or it is coming from the chatbot, and what is the content associated with that message. And we see, do we have any other message, first of all, do we have any session inside this conversation? If this is the first time message in that session, we simply initiate the conversation with the empty list, and then eventually we add this message, with basically a dictionary saying that this was the message from the user or bot, and what is the content. So that's what this utility function does. And then we require one more function. Since we are storing this conversation here, we need something that will fetch chat history based on the session ID. So we created one more function here which will take the session ID, and we can decide how many messages we want to retrieve from the past conversation. So if it is not there, it means it will simply return an empty chat history. If it is there, we will get the history, and we know history is nothing but the list of messages, because every time we insert one message like this, so we take all of those messages, and we decide if there are this, it's, let's say if it is a longer conversation, then we can decide if we want to only resend how many. So currently we are taking resend maybe 5 messages, right? And we are ignoring everything before that. So there are different ways how do we manage the conversation messages when they get the longer. You could summarize them, you could take the combination of summary and the recency, but for simplicity, we are taking the latest 5 messages and sending whenever we want to send it to the chat GPT. Okay, now I need one more. Once I get these history messages, which will be like this list of this dictionaries, I need some function to nicely format them. So I'm calling that history function here. I'm getting those history, and I'm formatting all that conversation as a big long string. That's what is happening here. Okay. Now I did mention here that when you create the RAG application, you need to make sure that follow-up questions are handled correctly. If the follow-up questions, we don't convert them into the standalone question, or we don't contextualize those questions, then we will get the wrong answer. What I mean by that, we know that every time user asks a query, we take that query, basically that user question, and find the relevant document. Now imagine if I ask this query, when was the green grow innovation founded? We calculate embedding of this sentence and match with the document, and we got something matching. But if I ask a follow-up question, because it's in chatbot, if I ask this, where it is headquarter, now imagine this question don't have any details about which entity I'm talking about. If I take only this question, where it is headquartered, and try to find the matching document here, then I will get any matching document related to any company headquarter, because that message is not complete. So what contextualizing does, it takes our previous messages or the conversation history and the follow-up question and convert into the complete question. So instead of saying where it is, or where is it headquartered, it says where is green grow innovation headquartered, because it knows that the first message was related to the green grow. Now if you take this message then it will go correctly and find the relevant document. I will show you proof here whether it works or not. Now, this I think diagram needs to flowchart needs to be updated, that even the chat history is playing a role in the semantic search if you want to build the working conversational RAG application. Okay, now let me show you a demo. We will see directly. So we write one more prompt which does this thing, which takes our first question. Instead of saying first question, I would say anything that the previous message is, basically chat history. So we got one prompt which says that we will give you the chat history and the current message, convert that message into this standalone question like this. And that is what the job of this particular prompt. This is a very standard prompt. You will also find in the LangChain. I also cover in depth here. That's the job of this particular prompt, the contextualizing the query. Now we need to update our prompt. Earlier our prompt was only taking the context. Where is the earlier prompt? Here, only context and the query, but now we are also considering the chat history. So I want to make sure our the function, we rewrite the new function which will consider that aspect also. So it takes the context, query, and also the previous conversation what we are. So this is the new prompt we're going to get. Now let's modify our generate response function to use that get prompt. There is no changes actually. It basically the same thing. Instead of it will be using our new prompt which has three things. Okay. Now this is the final conversational rack function which performs everything here. All of these things. Okay, what it does, it receives the query and the collection. It also receives the session ID. Since this is scattering the multiple user and their multiple session, we need to know which session we are talking about so that we can bring the relevant messages and the number of chunks we want to consider. I would say two are enough. Okay, so what it does, the first thing, it take the session ID and check, do we have any history messages? If it is there, it will format those messages as a long conversation history. We have seen already on the top what it does. It simply create that string with the role and the the message. Now once you have the conversation history, we are contextualizing query, because we know that we want to take the previous messages and the current query and convert into the complete query that we are asking. Once we have the complete query, then we can find the relevant document and source using that same function which we get the context. And finally, we will generate the response that has not just query and context, but also the conversational history. Okay. And we want to make sure whenever we get response, we add these messages to our, so this is the user message. This is the bot or assistant message to our chat history. We have seen the add message simply adds here to our conversation so that we can retrieve them later. Let's see it. I wanted to show you how this works without contextualizing and with contextualizing. Did I run this? Let's run. First we create the session because we want to make sure the user is able to have the multiple conversations separately. Next, we ask the query with that session ID so that it will make sure that for this session ID it stores everything, what query we ask and what the response we got. Let's run this thing. When was this green grow? So contextualized query, we got this basically rephrase of this query, which is not needed as such because it was a first query in session. So no value, it's not adding any value in this case. And this is what the response we got. The green grow innovations was founded. Now let's ask the follow-up question, because this is just same as what we have seen already. So if I ask where is it located, basically I'm not mentioning which entity. So I'm expecting the contextualized query will bring the name of the company inside that. So let's see what response we get. Okay, so it's saying the green grow innovation started in this small company somewhere here. Why? Because the contextualized query has taken where is it located and convert into the what is the location of the green grow innovation. So that's what I mean the contextualizing. It takes our previous message and makes it complete so that we find the right document. Let's see what happens if we don't contextualize it. So let me go back above and maybe we comment this part. This is where contextualizing happening. Let's comment this part so that directly whatever query we are passing, that is going. Let's do this thing and we will start the new session because we don't want those messages to be there. So this is the new session. This is the first message in that session. Okay, it is able to answer. This history is also getting stored. We can check whether it is getting stored or not. So what is that variable name? Conversations or something we have used, right? Where it is? Where? Yeah, here it is, right? Let's see what it has. Where are we are here somewhere, right? Let's put it. Okay, it's already here. I put. So let's see what it has. It has two session, right? Two, right? This is one session and this is the another session. The first session was this, which has these two messages. Third one only has this one single thread, right? When was it founded? Now let's ask the follow-up question inside that thread. This time we don't see any contextualizing happening, right? Now let's see what happened. So it is saying I can't answer this question based on the document, because now what document we got? We got document about this take wave innovations. We got document about this quantum next, which is not related to what we ask, which is the green grow, right? That's why it is very much important that we contextualize the query to get the right answer. So this is very much important to bring the right context. See, GPT has no problem with the conversation. It is anyway chat model, but since we are using the RAG, this part to make to get the proper retrieve document, you can't just pass the user query directly. You need to use some conversational. So maybe this flowchart needs to be updated. So when I add this code, maybe I will have updated flowchart that this user query and the conversational memory play a role together to bring the right context here. Okay, and let me run it again. Hopefully this time, yeah, now it works properly because it is able to contextualize query. So this is what we saw everything without using any framework like LangChain or the LlamaIndex, right? And we went through the all the steps involving this whole scenario. So let me repeat whole RAG system, which is conversational RAG. So simple thing is, normally what happen, you ask user query, it goes inside the prompt, we call the OpenAI and we got the response. But since LLM is not having access to your proprietary data, a enterprise data, let's say, then we need some way to bring that external knowledge to the LLM, and that's the part of the this is the part of the retrieval part. And how we build this retrieval? The first thing, all the document we have to process and store into the vector database. Then using semantic search, whenever user asks something, we can find the relevant document inside this vector database available and bring those documents inside the prompt. So we got a prompt which is made up of, let's say, query and the context, and then we send it to the OpenAI or any LLM API and get the response. This is nothing but the RAG. Whole thing is called the RAG. Now, what is conversational RAG? This user should be able to have the follow-up questions. OpenAI LLM don't remember you. Every time we have to send the messages that it is required. To do that thing, we maintain the user session. Every time user asks the first question, we maintain a session for the user, and whatever the conversation happening, what user is asking, what response is getting, we store those conversation in that conversation memory or the history, and we make sure we pass that history as a part of the prompt so that LLM is able to answer this thing. One thing I told, that this history should also be considered while bringing this retrieve document, because sometimes the user queries a follow-up question which is not the complete question, and we need to contextualize it using the conversational memory associated and bring the right document. I hope this video is useful to you. As I mentioned, the code and the the maybe the updated flowchart, if I update, will be available on mostly the future smart AI blog. I think we put all of our things here. You can even check, there are other awesome tutorials we have written recently. We have written on the OpenAI swarm, that framework. How do we add the langgraph long term memory to the langgraph agent? Even the recent fine tuning things what I have published. So we put our all the codes and explanation here, and it makes easy for me to go and change something here, because if something mistake happens in the video, it's hard to come back and redo that thing. But in the blog, I could easily access, and you will get the code and everything here for each video that what I'm uploading. So if you have any queries, if you have any suggestions, let me know in the comment. Thank you.